Okay, well, welcome. Welcome to this afternoon's session on Living on the Edge service. Bundling microservices to optimize consumption for devices with Spring Cloud and Netflix OSS. My name is Mark Heckler. I am a principal technologist and developer advocate with Pivotal Software, Inc. Pivotal, as you probably know, is a tiny little startup in Silicon Valley that has its hands in a lot of things. Makers of Spring Boot, Spring Framework, Redis, Greenplum, RabbitMQ, huge contributor to Apache Tomcat, and a giant handful of other things. I blog semi-regularly at my personal domain, thehecklers.org, not as regularly as I would like, just not enough time. And I tweet very regularly at mkheck. I kind of live on Twitter. Anyone else here on Twitter? Yay, okay. If you're not on Twitter, I also subscribe to the slightly older and more established social network called email. So if you think of something later, if you see something I missed, if I glossed over something, it happens. Let me know. Send me an email, DM me, whatever. So who am I? At times I ask myself that as well. I'm the author of several blogs and blog posts. I'm a co-author of one book and another one in the pipeline. I've contributed to several others. I love to read. I love to write. I love to share. My whole thought is that I have experiences you don't, you have experiences I don't, and the more we all share, the smarter we all get faster, which is a good thing. I'm a developer. I have worked for various consultancies over the years, and then for Oracle for several years, and finally now at Pivotal. Much happier, actually. I love open source. It's the model of the present and the future, make no mistake. And recently invited and accepted to be a Java champion. I'm pretty excited about that. It's a great honor for work with the community, which, again, community is what's important. And leaving Oracle opened a lot of new views into how broad and how deep that community is. So I'm loving it. Survivor of many monoliths. I was a hard convert to microservices because I could see some value to having everything in one place, basically, to summarize in kind of a one sentence statement. But when you struggle with things over the years, like large, lumbering, brittle systems with infrequent updates, that's the positive side. Anyway, that's the negative side. And ultimately, what you're wanting to do, in some fashion, is to deliver more value, more working software to production, because you can develop the best software in the world, and if you never get it to production, it's worthless. So again, I always look for a better way to deploy to production software with actual business value, not undifferentiated heavy lifting, as Adrian Cocroft, formerly of Netflix, says. So what are we going to talk about today? Not this. If you saw the title and thought, Aerosmith, Living on the Edge, this is not what you're going to get today. I'm not a good singer. I'm not even that funny. One of the examples that I show you later on is a quote database. I love quotes. I love history. But I'm not terribly funny or witty myself. If I were, I would do stand-up comedy. Instead, I do software development. And I feel like I'm much better at that and kind of hit my stride there versus trying to be funny enough to eat. So let me ask, who here is a current Spring user? Good. I'm a little concerned because a few hands didn't go up, but I'm hoping those folks are just asleep. So, okay. Spring Boot? Okay. Good. 12-factor apps, are you familiar with the concept? Cloud native? Okay. I kind of hit that all a little quickly. I don't, so many times when we go to these conferences, we look at advanced topics, which are great, but I think we lose some context, so I want to try to provide some more of that context here in this without getting bogged down in it. So I'm going to try to strike the right balance here and kind of build up from the ground up and talk a little bit as we go on all of those things. So Netflix OSS, Spring Cloud OSS, Pivotal and Netflix have a great working relationship. And Netflix has put a lot of investment and time and effort into building a lot of tools that support a microservices-based architecture, a robust, resilient architecture. And a lot of what they use are things like Spring Boot, obviously. Spring Boot, for the 3 or 4 who didn't raise their hands, allows you to leverage the full power of the Spring framework in a very consumable way in terms of cloud portable delivery mechanism. It brings all of the toys with it, so to speak. Spring Cloud, actually I'll just get into the next slide. There are several components that help you create a really solid microservices architecture, help you deliver more functionality in a more granular, scalable way. And Netflix has contributed a lot of these things. But Netflix deploys specifically to Amazon Web Services. So in many cases, they'll work with Pivotal engineers to create something that is more abstract, has more broad applicability. And sometimes it's a fact of Netflix obviously publishes their source, and we'll work with that after the fact as well at times to go ahead and abstract that. So instead of being tied specifically to Netflix's environment, for instance, the service registry that Netflix created is called Eureka. Spring Cloud also works with Kafka and I just drew a blank. Cloud Foundry, Console. I should go Console. Yeah, you can tell. The decongestants are good, folks. I'm just going to tell you that right now. But there are certain key pieces that you'll want to help coordinate your microservices and kind of give you a handle on them. Because when you introduce a lot of complexity into the mix, it tends to make things more difficult unless you add some tooling to help you with that. Is anyone here a Netflix subscriber? Okay, a few. I understand it hasn't been available in Spain for that long, so the early adopters, good on you, and everybody else, stay away because otherwise you'll spend half your time watching TV. So, but the Netflix webpage, I come back to that a couple of times throughout this, but the Netflix webpage has a lot of information on it once you log in. Welcome, here are your recommendations, here's your queue or your list of shows that you said you wanted to watch. Here are the top so many movies in each category. How many microservices do you think go into presenting the information on that page? Any guesses? Somebody's 1,000? That's overshot, but about 500, which is kind of a lot. So that lends an element of complexity. I kind of skipped over something in the previous slide. Whoops, going forward, not backward. Well, it was a great presentation, guys. Thanks for attending. Okay, you can tell I don't have my keyboard and everything set up the way I normally do because I'm kind of going, oh, where are the keys? Spring Cloud designed for fragile infrastructure in partnership with Netflix. The reason it says that is because with a monolith, with a large monolithic application, typically it's either up or it's down. And I know there are certain gray areas on that. But if you have certain functionality that's not available, chances are none of the functionality is available. With Netflix's page, if something goes out on that, you'll see things kick in to where, like the circuit breaker pattern, you have a mechanism in place to where it degrades gracefully. So you still provide some value to the end user without crashing the entire system. So the goal, again, is to increase robustness, increase resiliency. Here are the kind of key components. When you have 500 microservices, let's say, for instance, and a few instances of each, again, let's say 10 instances of each, just for argument, that's a lot of instances to try to keep track of the configuration for. With a 12-factor type of approach, you externalize your configuration. You shouldn't mix config in with your code because when you check in your code, you're checking in config. When your config changes, your properties, yeah, he's got the same thing I do. When your properties change, your connect strings, things like that, your resource locators change, you don't want to have to rebuild your code every time. So externalizing those means that now you have, I guess in some ways, something else to worry about across hundreds or thousands of instances. Spring Cloud Config brings all of that together and creates a central management repository for that without adding a bottleneck. So, we work with text every day, text values, text information every day. It's called code. And configuration properties typically are just text. What do we use to take care of our text, to version control it, to audit it? We use Git. So the Spring Cloud Config service uses Git underneath as its repository, but then it provides the API for our other applications to access it and retrieve and update their configuration. You also need some kind of a service registry so that your services can, if you will, log their presence into a phone book so that other services can find them. You don't want to introduce a new bottleneck. Again, this is not an enterprise service bus. All communication doesn't go through your registry. But what you want is for the services to be able to find other services. Once they ping the service registry, they'll get a cached list of addresses for all of the other services so that even if Eureka or your service registry of any stripe goes down, the system continues to run. Netflix also implemented things like Hystrix for the circuit breaker. And just like a circuit breaker in your house, if the wiring goes in your bedroom, it trips a breaker. You don't want your bedroom to burn down or your house to burn down. It provides you a way of gracefully degrading and protecting what's your system in this case. Load balancing, client-side load balancing, again, because you don't want to introduce any bottlenecks, your microservices cache the results from Eureka so they know where to go. And Zool provides intelligent routing, again, external to your code. This gives you some abilities like, you may have heard the term strangling the monolith. So when you have a monolith you need to continue to access and work with, you can have the routes defined in Zool and over time peel those off as it makes sense to do so. And security, Spring Cloud Security gives you HTTP's basic authorization, or authentication, excuse me. And then OAuth, we work with external and internal providers. Zipkin, distributed tracing, there are a lot of things I could cover today that we're just not going to have time to cover, so I'm going to just launch in now, and we'll see how far we get. Okay, yay, that seems to work. Okay, I assume you have all seen this page, start.spring.io, okay? You can get to this via command line. You can use curl. This is really kind of a nice centralized place. I like it. It's a pretty page. Hosted in PWS, by the way, if you're curious. We're going to create our config service to start off with. For the few of you who aren't familiar with this, you designate your dependencies you're going to add into this project. This creates a shell project. It doesn't generate code for you. It just creates your shell project and brings in your dependencies. The lovely thing about Spring Boot is that it version synchronizes your dependencies. Has anyone here lost hours or days trying to figure out why something doesn't work, only to find out that library A is on version 3 and library B has to be on version 7, not 8, for it to work? Yeah, several people. I was going to say the rest of you are lying, or else you're either asleep or haven't been coding long. So that's really fun, isn't it? That's really rewarding to give up 2 or 3 days trying to figure out what the problem is, only to roll back a version in a library. Spring Boot version synchronizes the dependencies that are tested for use with it. It doesn't mean you can't use other libraries, but in many cases, for instance, there are a pretty vast selection of pre-tested dependencies that we have in the Spring Initializer. So if you see it here, you can be assured that everything is going to work across the versions that are included. So a quick, oh, I should do this. A quick overview, you can use Maven or Gradle, doesn't matter. You can choose your version of boot. You can choose your packaging. If anyone is still having to deal with an application server, it does support WAR deployments, but again, you optimally for 12-factor bring all your dependencies with you. You bundle them, so you're not dependent upon something like a connection pool or something that has to be configured externally and crashes your app because somebody forgot to do it. So we always typically recommend you choose jar. You can choose your Java version. You can also not use Java. You can use Groovy or Kotlin, but who wouldn't want to use Java, right? Yep, okay. So kind of the way it works, you decide what dependencies you want. You generate the project. That, again, creates an empty shell project, zips it up, and then you can download this. And I was playing earlier, so there we go. And this is kind of the setup early on, so I'm going to kind of go quickly through this because I don't want to necessarily belabor the point, but it's important to have it set up and running. And really quickly, if you're familiar with, quote, the old Spring, you are probably familiar with the XML fun from days long ago. This is the only XML you're going to see today. That's the POM. And as you can see here, we've got the version for the Spring Boot Starter parent, and it's about as clean a POM as you're going to see, too. You have one dependency, but you notice there's no versioning information. All versions synced. So kind of nice. So let's go to our application properties. We're going to provide a couple of key bits of information, like our server port, so we know where to run this. And as this is our config service, again, this backends to, getting dry again here. This backends to a Git or SVN, but typically Git repository. You can point to a GitHub, GitLab, Bitbucket repo. You can point to a local repository on your hard drive or on a network drive. Probably don't want to, once you go to production, point to your hard drive, but for now it works pretty well, so we'll do that for the demo. I promise I won't do this in prod. Microservices, config. Typing's going to be a problem today, I can tell. All right. And then we go to our main class. And we basically direct it to be a config server. You notice how much code I've written to this point. None. I have assigned a couple of properties. I have added an annotation. And that is enough for between that and the dependencies in the class path to instruct boot on what kind of an application you want to come out the other end. And you can see here, everything's wrapped so tightly because it's shrunk. I need to, yeah, it's hard for me to relocate where everything is. I'm so used to my eyes going to one particular place. So let's take a look at our config service. And while that's coming up, let me go back to here. As I mentioned, this is a Git repository underneath. With text files, you can use standard properties, key value, one per line. You can use YAML files so you can nest. It makes it a little more efficient. I just have properties files here, but ultimately what you have in terms of options are an application properties is used for all applications. Any application that contacts the config service gets the properties in application.properties. You also can designate properties files based on platform or profile, so things like application-cloud for cloud deployments. And then you can specify a properties file for a particularly named service, a particularly named application that contacts your config service. So things like an edge service or Eureka service will pull back more specific properties that take precedence over the application properties in general. Make sense? Everyone still with me? Okay. So here's kind of the general application properties. If we go into, for instance, one of the other properties files, you can see further down that you have the application properties, of course, pulled in, but taking precedence are the properties specific to that particular service, named service. Okay, so let's drive on. We're going to next do our, why did I do that? Let's see, go back to simple version. Okay. We're going to next create our service registry so that we have some place for our services to register, to be found, to find and be found. So I'm going to create a Eureka service. We don't want to make this a config server. We do want to, however, make it a config client so it can contact our config service get the properties it needs to initialize and carry on. But we do want to designate it as a Eureka server. Makes sense. Generate the shell project, save, unzip, open. You'll see a similar sequence of events several times as we go through this. Okay, so I'm going to go back to my application properties, and here's where we diverge just a little bit. Because with Spring Cloud applications or microservices, let me back up. With typical Spring Boot applications, you'll have, again, the application.properties. This allows you to designate some properties kind of out of the gate. So when the application is initialized, it looks to that file for its property settings. You can override those. Again, there's a precedence, so you can pass in something on the command line. It will pull the environment and pull in environment variable values, which means it's portable. You're not coding in your config into your programs. But for Spring Cloud, for microservices applications, you want to kind of get in front of that application initialization. You want to somehow, in the bootstrap phase, reach out to the config service, get those properties, and then initialize your application. Makes sense. So rather than an application properties, what we will need to do is create a bootstrap.properties file, which effectively does the same thing but allows you to reach out and hit that config service. So the things we need to provide are our application name so it can identify itself properly to the config service. And we also need to tell it where to find the config service. Excuse me. Okay. And then we need to, again, direct this that it's a Eureka server, up and running. By the way, I'm running all this through my phone connection because I want to be able to, assuming I have time later, to do some async messaging. And for routing, in order to access my VM and Docker image or Docker container running, for some reason, some Wi-Fi connections don't seem to support that. The phone always does. So it's a little sluggish, but again, pretty respectable. We can see here that it hit port 8761. It initialized to that, which is exactly what we told it to in our properties, as we can see. So let's go up and take a look. This is the Eureka Dashboard. Interesting information here. It's not used by your microservices. It's used by you. So you can see what's going on within your larger system as a whole. The important bit here is the instances registered with Eureka, because that's where you'll see your various services as they register with the service registry. So at this point, we have none. Let's fix that. So let's create something as a backing service. I mentioned I like quotes. I don't have any right off the top of my head that are really clever and pithy, so I'm just going to make stuff up. But unless somebody has one they want to shout out, and then I'll gladly use that. But we're going to continue wanting this to be a config client. We're going to hit our config service to get our configuration. We're also going to expose a web interface. We need it to chat with Eureka so it can register with Eureka. Excuse me. We also, it wouldn't be a very good quote service if it didn't store and retrieve quotes. So we're going to provide some mechanism for doing that. I'm going to use JPA because, as my colleague Josh says, we make poor life choices sometimes, so why not propagate that, right? I'm going to select H2, which is an in-memory database. JPA works a treat. Wouldn't use this in production, but it demos well. By all means, if you want to use a NoSQL database like Mongo or Couchbase, if you have data that makes more sense in a graph type of rendering with Neo4j is supported, or you can bring your own. But for the demo, we're going to go with JPA and H2. I'm also going to bring in a dependency for REST repositories. That allows us to leverage Spring Data REST to take our defined entities and to handle our storage and retrieval and expose REST endpoints for us based upon those. Let's see. We'll also optimistically pull in our Zipkin client. I'm also going to bring in Hate OAS. I know some people pronounce that differently. Those people are wrong. I have worked with a product called OAS in years past. I can assure you that Hate OAS is the proper pronunciation of that. If you don't want to pronounce it that way, that's fine, but I'm just telling you that's the right way to do it. And then the HAL browser, which is a really nice little way of exercising your REST endpoints for the price of a free dependency. Let's see, what else? I want to bring in, I'm going to bring in, there we go. I'm going to bring in StreamRabbit. I actually wind up switching it out to Redis because it gives me an excuse to show you something else, but we'll bring that in anyway. And what am I missing? Anything that I'm missing? That will probably work for now. Okay. All right. So let's do the download. Unzip. Open. Okay. So again, we're going to do the same thing again with our application properties. We'll rename that to Bootstrap. Always works better when it's not Bootstrap. And again, we will provide our application name, which is quote service, and our config URI. Okay. We are going to, in this case, be sure and tell it that we want to have it act as a discovery client. So we want it to register with Eureka. Excuse me. Okay. At this point, we have a working application. We can run it. It will register with Eureka. It just won't do anything. So let's, it's not a very good quote service if we don't do anything with quotes. So we're going to create a quote. We're going to, we're going to create a JPA entity. This is an annotation that's not specific to Spring. It's JPA. We're going to define our entity. We'll call it quote because, again, I'm not that original. So we're going to give it the fields that it needs to be a valid working quote. Quote should have text. Quote should have a source. And then we're going to assign it a constructor. We'll give it a no-arg constructor for JPA and JSON marshalling and unmarshalling. We'll also give it an actual useful constructor, and then we'll give it some getters and probably a toString. And that should do it, except for one thing. Being as how this is a JPA entity, we need to designate our ID field. And we need to provide some mechanism for instructing our data engine how to create the value for the ID field. So we'll tell it to assign it by its default method. So again, now we again have a working application that still doesn't do anything. We have an entity defined, but nothing's going in there yet. So let's, I guess, first create a repository REST resource. This allows you to define an interface. We'll call it quote repository, if I can type, and to extend an existing defined repository in Spring Data. CRUD repository gives you the capabilities to do create, read, update, delete. There are other options, but this is a pretty nice jumping off point. You designate your class type and your ID type. And that is enough for Spring Data REST to make the associations and provide a certain basic level of functionality. I'll show you, actually I'll take a quick moment and run that in just a moment. But what we want to do as well is to populate it with a few quotes, populate our quote repository with a few quotes. So we're going to create a command line runner bean. And anyone here familiar with Java 8? Anyone using Java 8? Okay. Not as many hands go up as they'd like, I bet, probably. But what we're doing is defining our single abstract method within our interface for command line runner. When we create the bean, it goes ahead and executes that, gives us the ability to do something like this. I'm going to bring in the quote repository so that I can do this. And we'll save a few quotes. Anybody have anything original? Hola mundo. Okay, well, we're just going to have to go with whatever comes off the top of my head, guys. That's not going to be brilliant, but...
There is no spoon.
What's that?
There is no spoon.
There's no spoon? Okay, I have to know. Where did this come from? What am I missing?
Well, the little boy from Matrix.
Oh, gosh, I forgot about that. That's been so long. Okay, so what was his name? Do you remember?
Little boy.
Yeah, okay, little boy. I like that. That works. Okay, another one? Anybody?
I am your father.
Okay, I'm not even going to ask who said that. I am your father. Some dude all dressed in black. Yeah, Darth Vader. Okay. All right, so we have some quotes, but let's go ahead and do a quote repository.findAll.forEach system.out. Oops. Print line, so we can at least see that it's happening. We see that the values are being saved. Now, let's run this, because this gives me a chance to show you a couple of things really quickly. Yikes. Okay, it started. So we see here our quotes are present. We also see this. Does anybody recognize this? Again, I'm a history buff, so that gives you a hint. You see the port number? That's pulled from our properties. Does anyone recognize that number, 8088? History's fun, guys. Come on. History in our industry is fun, too. That's an old processor number from Intel from 100 years ago. Yeah, slightly better than a calculator. But anyway, it's history. Okay, so let's go out and take a look. Here, this is our HAL browser. Again, I included this as a dependency. It gives you a chance to go through and navigate. So you can see that Spring Data REST has done a little of that undifferentiated heavy lifting for you. You've defined a quote entity. It has created a quotes endpoint for you so that you can get and go through and you can see each of the individual quotes. You can do a non-get, so you can do a delete. You can do a put. So it gives you the opportunity to do a lot of work just kind of for free. Kind of a nice little extra. So let's see, anything else I wanted to show there before I go back? Probably not. Okay. So that's nice, but so far all that's done is given us the ability to pull back all of our quotes. Does anyone here have a quote of the day application on your phone or have a site you hit every once in a while? What do you guys do for hobbies? I mean, I know I'm kind of lame, but you know, that's cool, you know? I always like it when you see some really thoughtful, pithy quote from somebody else. Pithy, TH, not SS, but anyway. So we're going to create that. We have our quotes. It would be nice to randomly pull one up based on, well, again, randomly, and supply that to an edge service or other microservices that may want to use that. So we're going to create a, whoops, I can't type. We're going to create a REST controller, call it class quote controller, and we're going to define a request mapping so that we can, whoops, do our random endpoint. Within that, we're going to, let's see, public quote, get random quote. I know it doesn't matter, but I'm going to fix it anyway. And we're going to need to get to our quote repository in order to access that, right? But here we run into an issue, because at this point, you can see we don't have any way of pulling back a random quote. But we can fix that. Again, Spring Data REST gives you a lot of capability for free out of the box, but we can also, you hear Pivotal talk about being opinionated a lot. Some frameworks, some tools impose a particular way of doing things on you. You don't see that within the Spring ecosystem. You see an opinionated approach, so that if you fall within the 80 or 90% of the typical use cases, you don't have to do a lot to get a lot of value. However, if you fall outside of the majority of use cases, it gets out of your way quickly so that you can do something useful. What we're going to do is define a query, something along the lines of select Q from quote Q, order by rand. And we will define this as returning a list of quotes. Get quotes. This won't be anything fancy, but it will work. Random order. And this is enough by specifying the method signature and the query that you want it to use for Spring Data REST to hop into action and provide this method for you. So at this point, we can go back, and get quotes random order, get, 0, and we'll return that. And voila, we now have, in just a few lines of code, the ability to get our random quote, which serves as our foundation for where we're going next. So we'll at least verify that this works. Okay, so let's take a look here, and we can see that we have our random quotes coming up. Okay, so good stuff, right? So let's go on to something a little more fun. We'll go back to Spring Initializer, of course. That's where we always start. We always start there. We always go back there. We love Spring Initializer, right? We will still want this to be a config client. We still want to expose a REST interface, REST interface. We want it to be a Eureka client. We won't need JPA, we won't need H2 because we're not, with our edge service, doing the actual physical retrieval or storage. We're not going to need our REST repositories. We'll still want to include our Zipkin client, HateOAS, HAL Browser, StreamRabbit, which that reminds me of something I forgot to do earlier. No big deal, we'll get to it later. But we also want to bring in things like Hystrix, as mentioned, for our circuit breaker. We also want to include things like Ribbon for our client-side load balancing, and finally Zool for our intelligent programmable routing. And let's also include Actuator, and we'll generate our project. Open, Sesame, and quickly we'll go to our application properties again. And rename that Bootstrap, not Bootstrap. And provide the Spring application name, which will be Edge Service in this case. And again, point it to our config service. Okay, so go back to our application, indent. We're going to do things a little bit differently this time because we're going to annotate this as a Zool Proxy. What this does is enable Zool Proxy as a meta annotation. So it includes Circuit Breaker as well as your Eureka Discovery Client, excuse me. So it brings it all in, everything that we need to go forward and provide the mechanisms that we want to provide. So as it is, and I'm going to go ahead and just run this now because I want to show you something as it stands. Again, the nice thing about Zool is that you can define your routing intelligently outside of your code. So if we look at our properties, we can see this. I've defined some Zool routes, and the first line, anything, when you're accessing your edge service with the URL /QS anything, it will look for the quote service. Again, it's Eureka aware. It's a service registry aware. So it will look for a service called quote service, and it will forward to that. That's what's called a micro proxy. So you don't have to do any coding to enable that. You effectively designate your application as a Zool proxy, and then your routing information takes over and does the rest. So just to show you kind of what that means for you is if you do that, then you can see that you get the same results as on your backing service. The only thing that's different is, of course, your hypermedia links reflect your path for getting there, in effect. So again, that's kind of nice. It gives you that capability at no extra charge or no charge at all. With Zool routes, you can also define various routes which let you forward to local or remote endpoints. I'm going to create a local endpoint to kind of show you the manual way, the kind of the hard way of doing it, so to speak. But it works the same whether you're using a remote endpoint, and it kind of shows you, in effect, effectively what Zool accomplishes for you. So we'll go here, and we'll create a REST controller, class quote controller, and we'll do a request mapping, and I'm going to call this, because this is what I called it out in my Zool route, quotorama. And we're just going to return a string. We're not, because with an edge service, typically you'll do some kind of manipulation. I mean, typically you're not accessing a single backing service. You're, like Netflix, you're accessing several of those and providing some kind of added value, manipulation, marshaling of information to provide it in one cohesive chunk via one call to a mobile device or some kind of an edge device. I'm going to simulate that very simply with just returning a plain old string. So we'll get random quote, and we need to first create a load balanced bean for our REST template. Okay, so, oh, yeah. Tell I'm looking at code too long. It's just, golly, here we go. New REST template, wow.
You still need the quotes method.
Yeah, I'm just, okay, we're good. Yesterday, I stared right past an annotation that I had wrong, and I just couldn't see it, so extra eyes help, guys. Okay, so we're also going to leverage that here by injecting it. And all right, return REST template, get for object, and we're going to use our quote service. Again, this is Eureka aware. And oh, there we go. And wow, okay, so we are grossly over, or almost about to be over time. So I'm going to make this somewhat brief. This allows you to, I'll directly, of course, go to the endpoint, which gives you exactly what you would expect because you've defined your endpoint here. But you can also, using Zool, use your defined path that you laid out in Zool as well. So it's a little way, kind of a long way around the barn, but that shows you that obviously it's still using Zool. You can hit a local endpoint. You can access your services. It's Eureka aware, so on and so forth. I do want to really quickly just show you that your circuit breaker pattern. So I will make that quick, and then I guess we'll have to stop because I don't want to be a bad citizen here. We're going to define this as a Hystrix command. What this allows you to do is create a fallback method so that if something happens, if this method returns an exception, you don't introduce perhaps a cascading failure in your downstream microservices. So we'll need to define a fallback method. So let's see, we'll do a public string get default method, and we will return something. What I usually do is show a little bit more interesting stuff, but again, in the interest of time, we'll just kind of compress this to our quote that we're going to pull in from our config. So we'll do quote, and then we will pull that in. All right. The only thing we have to do, of course, is designate that as our fallback method, because if we don't do that, it doesn't do anything. And then we'll restart. Wow, how quickly time flies. Okay. All right. Okay. Okay, so actually, we have just a little bit more time than I thought, so I'm going to push my luck a little here. All right. Okay, so kind of debating what I want to put in, what I want to not. All right. We have created our Hystrix command. We've defined our fallback method. So at this point, we can go and we can see that no problems, we're able to get to our backing service. However, if we go out and kill our backing service, because we never liked that thing anyway, now we see this. So this is our default quote, which kind of makes sense, right? Whenever the question, coffee is almost always the answer. I'm a big coffee fan too, so coffee, history, quotes. So I always say I love my wife the most, but behind her are all those three things. So I could show you some other things as far as restoring and using actuator to go ahead and refresh so you don't bring down your system, but that's at a much I guess more simple level than what there's several things that I could show, so I want to actually show you a little bit of asynchronous capability. So let's go ahead and get this started again, actually, since I have this down anyway. One thing that I forgot to do is change out my stream rabbit for stream Redis. I'm using Redis because I'm lazy, not because it's a good option. It also gives me a good chance to show you this. Because remember how I said that everything was version synchronized when it was tested and placed on the main page for the Spring Initializer? You can see here this isn't. So you can bring your own tools, bring your own libraries, but you're going to need to obviously tell it where to find it, what version to use, and then I'm going to incorporate my repos in there as well. Yep, enable auto import. That's cool. And then go back to here. I'm going to do the same thing in my edge service, and then we will step through the setup of that. Oops. Click happy here. Just do this. Happy. Drop that in, and then quickly go up to rabbit. We'll change that. And, oh. Yeah. Redis, happy. All right, so that's cool. Now, I just want to make sure that I did what I think I did. Okay. Oops. Wow, I'm not able to even see what I'm doing there. Let's see. Okay, that should work. If not, we'll find out very, very shortly, right? Okay, Spring Cloud Stream allows you to leverage asynchronous communication. Obviously, reactive is a big thing. It's a big deal, and that's kind of where everything is headed. However, it's not the only asynchronous method you have at your disposal to handle communication where you don't block. So things like RabbitMQ, Redis, you have options for integration even as we speak now with existing systems. So what I like to do is show some asynchronous messaging. It gives you a little taste of it. It's very easy to get started with. For the edge service application, what we're going to want to do first is enable the binding so we can tell it to act as a source. What happens with an asynchronous message queue is that you'll define a service as a source, and you'll define a service as a sink, or multiple services as sinks, so that you can, in effect, push a message onto a queue and then retrieve that message as it pops out the other end. We're going to, from our edge service application, because we want to be able to asynchronously add a quote without any kind of tie-up. We don't necessarily need any confirmation. We just want to pop a quote out there. What? So we're going to add an endpoint. Let's see. So, and we will make that, oops, value new quote. I'm trying to hurry, and it's just getting ahead of myself here. So request method post, because we want it to be a post. We will do a void send message. And we haven't defined our quote, so I'm going to, I normally just quickly code this. Why not, right? Okay, so we will do class quote, private long ID, private string text, private string source, and again we'll do our, hate when I do that, constructor, select none, then we'll actually add a useful constructor, and then we'll do our gets, and that's good enough. So we are going to provide the means to do this. And we'll also need to auto wire or inject our source quickly. And we'll send this as a builder dot with payload, and we are going to provide our quote dot build, and voila. So that should handle our source side of things. We also want to, or need to, go to our quote service because, again, we have to have something to get it coming out the other end. We'll enable binding for our sync, not sing. Yep. And we will create a message endpoint. Class my message endpoint. Okay, here we go. This is kind of a nice little extra. There is a stream listener that in the past what you've had to do with like service locators is provide your own type marshaling and type coercion. We're going to leverage stream listener to do that for us. So let's see, void add quote. And we will also, of course, need to inject our quote repository. Really quickly, we're almost there. Almost there. Save. quote. And then we'll also, just as a matter of principle, want to watch it happen. Okay, so that should, at least in theory, work, right? Let's find out. If not, it won't be for lack of effort. Okay, so start rerun.
There's an S somewhere at the end of the line. Letter S, please store something, send something.
Oh, so it is. Oops. Typos kill me. All right, so let's fire up Postman because that's kind of a nice little tool for doing exactly what it sounds like. So we're rerunning. Everything seems happy. Happy is good. Happy is good. All right, so I already have a test quote here. And again, asynchronous, you should have idempotent operations, so you're not trashing your data if you send it more than once. And if we go out and look, there we go. Went in one end, popped out the other. Everything as we'd expect, fully asynchronously using message queuing. I am just at the end of my time, so I'm going to call it a day. Good? Bad? Anything useful? Thank you very much for coming.